Hey, Hannah. So for that, I was just looking at that problem you gave me, and I think I was actually just about there when we were talking on our little Zoom meeting. And so the basic point is this: is that we have only one torque acting on that disc that's spinning, and that torque is due to the friction between the disc and that rod that's holding it there. And so what it says is, I'm trying to be careful about how they define these different values. I think it said that the frictional torque is tau naught. And so that's going to be equal to the moment of inertia times the angular acceleration. Because keep in mind, this is sort of our Newton's second law for rotational, or for torque. So that's torque is equal to moment of inertia times the angular acceleration. And if it's a disk, we know that this angular, or I'm sorry, if it's a disk, we know that the moment of inertia is just 1/2 mr squared. I had to look, I always have to double check because I never remember what the different moments of inertia are. But okay, so we have 1/2 mr squared. And then it wants to know what the angular velocity is. Well, keep in mind, if our angular acceleration, alpha, is equal to, well, keep in mind, it's equal to the change in the velocity, the angular velocity, over the change in time, t. And so if we want to solve for the angular velocity, we can just plug this in here. And we can say then that that's equal to omega over delta t. And then we can solve for omega. So we can just say that omega then is equal to tau naught times, well, there should be a 2 in front, right? Because we're going to bring the 2 over to the other side. Tau naught times delta t all over mr squared. I think that's what the problem is getting at. Let me make sure I did my little algebra right here. So if we, okay, so we have tau naught, bring, okay, t. Okay, yeah, so I believe the answer then would be omega is equal to 2 tau naught times delta t over mr squared. I think I remember that those were all the variables that they give us. So I think that should be the answer.